properties of graphs. So some of this stuff is going to be similar to the stuff we talked about with our functions because functions have graphs. So some of it will be very similar, but some of it will be a little bit different. So on this first one, it says use the graph of the function f, which is shown in the figure, to find a, the domain of f, b, the function values of f of -1 and f of 2, and c, the range. So remind me, what type of values are my domain? They're the x values, okay? If my graph has a starting and a stopping point, then my x values will also have a starting and a stopping point. So where do our x values start for this function? -1. Where do they end for this function? 5. So remember that we have two notations. The first is our set builder. So we would have x such that it has to be between -1 and 5. Do either of those get an equal to bar?
No. Wow.
The first one does,
Yeah.
because I have a filled in circle versus my second one does not because there is a open circle. So remember, we can use set builder notation or we can use interval notation. So we would have -1 to 5. And I don't care which notation we use, but you at least need to be familiar enough with both of them that if I give those as like an answer or in your instructions, that you know what they mean. Now on part B, it asks us for some function values. So f of -1. -1 is which type of value? An x value. So how do I find the y value? What am I looking at?
The y-axis.
Not the y-axis.
So wherever the -1 is.
Okay.
You look at the y.
So what am I
So
looking
one.
for? Yeah, 1, because I'm looking at that point, right? So I go to my x is -1. I see what point is there. So in this case, it is 1. What about f of 2? So if I go to 2, I come down, it would be -3. Now it doesn't ask us this, but let's talk about it. What is f of 5?
2. No.
It is not 2.
It doesn't have. Then it's not.
It doesn't have one because it's an open circle, so
Why?
it would be
Why?
undefined.
Why?
Yes.
It's still.
It's not a
No,
point
it's not included.
because it's not filled in, right? So for my y values there, I could get really close, so I could get to 1.99999, but I don't have a value actually at 5
Why though?
Like,
because it's an open
It's
circle.
how do we graph
It's
that?
an
Like if
open
we get an
circle.
Because that's the graph they gave us.
okay, how do we graph that though? So it's like we have an equation and we're graphing. How do we know that it's something like that?
If you had a rational function where your factors reduce, you have an open circle. But we won't get into that until another chapter.
Okay, never mind then.
So right now we're just looking at the graph that they give us. You don't actually have to graph it. But do y'all understand why from the graph it's undefined?
Because it's open.
Because it's an open circle.
Exactly.
Alright, now for part C, they ask us for the range, which are going to be which values? Your y values. So for my y values, what are my y values in between this time?
3. -3.
0.
3 and -3. Alright, on -3, do they get equal bars this time?
3. Wait.
Yeah.
I thought it'd be 1.
They do.
Well, but I go higher than that, right? I go to here.
Oh, it's your
My highest and my lowest because they're my y values. So I'm saying, what are my y values between? My lowest point is at -3. My highest point is at 3.
Okay.
Or we can list it as -3 to 3, but both of them need hard brackets this time. Questions on that? So we need to be able to find different things given the graph. Alright, so we talked about this a little bit yesterday, so let's look at some more examples of it. Using our vertical line test. So remember we talked about that. If I draw vertical lines through my graph, okay, what tells me if it's a function or not?
The number of times it goes through.
Correct. So if it touches it 0 times, could it be a function? Yeah.
Yeah.
It won't be continuous, but it could be a function. If it goes through it 1 time, is it a function?
Yes.
Yeah.
What about 2 times anywhere?
No.
No. What about more times?
No.
So on my first one, is it a function?
Yes.
Yes. No? Which one?
What?
How many times does it pass through it?
Twice.
Twice. So is it a function?
No.
No. There we go. On my second one,
I said no.
yes,
Yes.
Yes, the one time.
it is.
As in.
Yes. What about my last one?
No.
Yes.
Yes.
Yes. It's just
What?
not continuous.
Correct. So
I'm
this
so
is
favorite.
a function, but it's not continuous. But it doesn't ask us if it's continuous or not. It just says, is it a function? So no spot on my graph, if I were to draw vertical lines, is it going to pass through more than 1 point. It's okay if it passes through 0 points on a spot. It just can't pass through 2 points, like it does on my first one. Are we all okay with that? So what are our zeros of a graph? Yep, zeros of a graph. Or a function. Either way. They're your x-intercepts. What's another way to describe them?
Intercepts.
X-intercept, yeah.
And one.
What?
And one.
No.
Or not.
Zeros are only your x-intercepts.
Why can't you just call them X and X?
You can. There's just different words for them. What's the other words for them? Your roots. What else? There's one more. So remember that your zeros are the x values. That make f of x equals 0. So I would have a equation, solve the equation. So what are our answers called when we solve an equation? Your solutions. So you could see me ask it for either any of these. I could say find the zeros of a function. I could say what are the roots of a function. Okay, any of those all mean the same thing. I'm setting f of x equal to 0 and solving. So what does it mean to plug in 0 for x? What would those be? So setting f of x equal to 0 gives me my x-intercepts. If I plug in 0 for x, I would get my y-intercepts. So just be careful with those. So on my example, it says to find the zeros of each function. So what are we doing in order to find the zeros? Plug in 0 for, not x. We don't have a y, but we have an f of x, right? And those mean the same thing. So we have 0 equals 3x squared plus x minus 10. What type of function is that? It's a quadratic. So how do we solve quadratics?
Quadratic
Formula.
That takes
Oh
much
my
longer.
God.
We want to
But I
factor
know it.
first. If it factors, then that's how we want to solve it. If it doesn't factor, then yes, we can use the quadratic formula, okay? But this does factor. So I'm looking for what two numbers multiplied together to give me negative 30 that add together to give me 1. What are they going to be?
6 and 5.
6 and negative 5. So then remember that we use those two numbers to break apart our middle term. And then we factor by grouping. Now, once we have our two factors, what do we do with those two factors?
Oh, put them to 0.
Set them equal to 0. So we would get x equals negative 2 and 5/3. Not 5 halves, 5/3. Questions on that one?
It's, you take turns plugging them in. Each one to find y.
Huh?
You plug in -2 to x now to solve for y or not.
No, that's my answer. My zeros are my answer. If I plug in negative 2, you should get 0.
Okay.
Right? Because I said it equal to 0 and they're my x-intercepts. So y should be 0 if I plug it back in. Does that make sense? So if you wanted to, you could check your work that way. But those would be your final answers. Alright, what about part B? What's different about it? What does it have?
Negative.
What does it have?
Those are right.
It has a radical. So I'm still going to set it equal to 0, but my steps are going to have to be a little bit different. I'm trying to solve for x, so we have to undo the radical. How do we undo a radical? Square it. Can I just square the radical?
No.
I have to square
And
both sides, right? But if I square 0, what's nice?
0.
It's still 0. So we get 10 minus x squared. Now, what type of function do we have? The quadratic. When I have two terms on a quadratic, what are my options to factor it? We talked about some special formulas. Difference of perfect squares. Is that a difference of perfect squares? Is 10 a perfect square? No, so I can't use my difference of perfect squares formula. Do I have a b value here? No, remember b value is what's with x, right? So I have an a value, it's -1. I have a c value, which is 10. But if I don't have a b value, it's not going to be very helpful to do my AC method either. But what could we do instead? If it's not going to factor, what could we do? How would I get x by itself?
I would move the 10 over to the other side. Oh my god.
You could. I mean, I would probably move my x squared over just so it's positive. But either way. Then what could we do? How do I get rid of the squared?
Unsquared the
Unsquared. So what's that called?
like square root.
Square root.
Oh yeah.
So what do we get? X equals plus or minus the square root of 10. Now, why was I able to square root this one, but not my first one?
Because the other one was complicated.
Okay, but what made it different?
Because it was
There's no b. There's no b.
Because there's what?
more than one thing.
Agreed. So this one has 2 terms, right? This one has 3 terms, which means that it has a what value?
B.
A b value. If it has a b value, that means I have an x in it. So even if I moved everything to the other side, if I tried to take the square root, I'm taking the square root of stuff that has x's in it, and we're not allowed to do that in order to solve. Does that make sense? Now, on my second one, I don't have a b value. I just have a number. We're allowed to take the square roots of numbers, so that's okay. Are we all alright with that? Do you see the difference between those two things? Like why they are different? Okay. So then on part C, okay, this time we have a rational, okay? What is a rational, or like what part of a rational is allowed to equal 0?
The top.
Just the top, right? The numerator. So we know that if my bottom can't ever equal 0, we don't care where that part equals 0. We only care where the top equals 0. So we set the top, which is 2t minus 3 equal to 0. And we solve, and we get that t equals 3 halves.
That's it?
Yep. That's your answer.
So you just have to do the top.
Because remember, the bottom equaling 0 will either give us a whole or an asymptote. It's going to be undefined there. So if my top is 0, it doesn't matter what the bottom is, because 0 divided by anything will give me 0. So I only care where the top is. Other questions? Okay. So let's look at some properties of graphs. So when is a graph increasing?
When it's going up.
Okay, I'm going up. Is that increasing?
When it's going up to the
Right.
right.
Okay, is there a way to describe that besides to the right?
Positive slope.
Positive what? Okay, we don't want to talk about slope because I could also be talking about things that are curvy, and those aren't going to have slope. Now, increasing is kind of equivalent to a slope, but we can't say slope because only lines have slope. So what's happening as we go to the right?
Your y value is increasing.
What's the relationship?
Correct. We want to look at the relationship between x and y, okay? So, what's happening as we go to the right?
Becoming more positive.
What's becoming more positive?
The X and Y.
My,
Your y.
no, what, just specifically, if I'm just talking about left and right, which value is that?
just
That's just x, agreed?
Yes.
Yeah.
So, as I move to the right, which value is getting bigger? X's, okay? So, as x increases, okay, now we can say, in order for our function to be increasing, right, we said it has to go up, so which value describes up? Your y values. So what has to be happening to your y values? Y also has to be increasing. Now, what about decreasing?
Is it constant?
It's just the opposite, but
No, we're gonna talk about parts of the graph that are increasing or decreasing. So the whole thing doesn't have to be one or the other. You could have different parts that are one thing or the other.
this is the opposite.
So I would say as x decreases, y also has to decrease?
No.
Why not?
Yeah.
As the
can also-
X increases, the Y decreases.
Because I still want to move from left to right. If I switch both of them, as x decreases, I would be moving from right to left. And we don't want to do that. We want to say as x increases, now our y is decreasing. Now, what about the last one? Again, I'm saying as x increases, what's happening to my y values this time?
Y doesn't
Stays the same.
y.
Okay? So for all of those, what's that first part? Like what are we looking at first?
X.
Your x increasing. So that means that when we're describing parts of our graph, we're looking at x values. And that's going to be important here in a second. So it asks us for when these graphs are increasing, decreasing, and constant. So on my first one, where is f of x equals x to the third increasing? Or getting bigger? What's the issue?
In the middle it's constant.
Are we sure it's constant?
Actually, it like goes down.
Well, it doesn't go down. I mean, your slope does approach 0. So let's look at our graph. Yes. Is it an emergency? Yes.
Good job.
Alright, so notice here, it looks like I'm increasing on the left and I'm increasing on the right. The issue we're talking about is when we get close to 0. So let's look at our y values. What's happening to our y values?
Increasing.
Are they still increasing?
Yeah.
Yeah, they're still increasing. The reason that we get 0 here is because it's so small of an increase that it's rounding to 0, but it is still increasing. So even if it's increasing really, really slowly, that's still increasing. So where would our function be increasing? Everywhere. So how do we describe everywhere in terms of x values?
Infinity.
Yes, so which one comes first? Negative infinity to positive infinity. Agreed?
Why?
What? We're all okay with that?
Yeah.
Yes.
Okay. Now on our next one, where is it increasing?
All the way to -1.
Okay, so how would I describe that? Negative infinity to -1. Is it increasing anywhere else? From 1 to infinity. Why didn't I use -2? Because it's the y value, and we said that we're going to describe this using x values.
Oh, I get it now.
So, where are we decreasing on this graph?
That was fast.
From -1.
We are decreasing from -1 to 1. Alright, on our last one, where is it increasing? Negative infinity to 1 to 0, because it's our x value, right? Where is it decreasing? 2 to infinity. Is it still positive infinity even though I'm going down?
Yeah, it's forward.
Because I'm still going to the right. So my x is still getting bigger. So my x is still going to positive infinity. What about where is this graph constant? 0 to 2. Yes? No? Maybe?
If it was a constant
look at
increase, how would you write that?
That is decreasing as it gets bigger.
I never.
I'm not understanding. Oh, like if it was decreasing, I would just write decreasing and it would still be negative infinity to infinity. It would just be like if this was flipped, right? It would be going down instead. But it's still decreasing from negative infinity to infinity. So the parentheses would be the same, you would just label it differently.
And we only look at the x.
We only look at the x's. And the reason for that is like notice, technically like here in the middle, my y value is 0 at 3 different places. So if I described intervals of y, I could be talking about 3 different places. Versus my x, I can only have one x value of 0. So I can only be talking about one point on my graph. Does that make sense? And that's why. Alright. So lastly, we're talking about relative mins and relative maxes. What does it mean to be a minimum or a maximum?
The highest or the lowest.
The highest or lowest what? Amount of what?
One.
The y value. Okay, because we're talking about highest or lowest, we're talking about up and down, which are our y values. Okay? Now, the relative part means for stuff that's kind of around it. So, for our minimum, we would say the lowest y value in an interval that is close to the point. Now the reason that I put close to in quotations is because close to is not a mathematical term. The problem is that in order to describe it more accurately, you would need higher level math stuff that we haven't gotten to yet. So for right now, that's the best definition that we can give it. Okay? For our relative max, it's going to be pretty similar. It's just going to be the highest y value in an interval that is close to the point. So, you may also see these described as two other words. The first is going to be the extrema of a function. It's basically the extrema because you're talking about the extremes, the lows and the highs. Okay? The other word that you can see used is the turning points of a function. And we'll look at why in just a second. So on this graph, I want us to label our relative mins and maxes.
Oh.
So do I have a lowest point?
Yes.
Yeah.
What's it at?
Around negative.
So what's the point? -2, -4?
Yeah.
So that would be a minimum, correct? That would be my absolute minimum, because it is the smallest point of all of them. However, do I have another point that's the smallest point for stuff like around it? Yeah, which one? 4, -1?
It's like all the good.
Yeah, so remember that's why it's called a turning point, because basically we're going from decreasing to increasing. And that's going to give me a relative minimum. So we also have a relative minimum at 4, -1. Now, do we have an overall maximum of this function?
No.
No, because these arrows go on forever up. So there's not going to be a biggest point. However, do we have a relative maximum?
Yes.
Yeah, what's it at?
2,
2, 0. Because that's where it switches from going from increasing to decreasing. So that's where it is turning on our graph. Yes?
For -2, -4, do we label that absolute minimum or relative?
So it's both. So your absolute minimum is also a relative minimum.
So would we write like absolute minimum?
Or you can just combine them with the.
It would depend on what the question is asking. If it says to label the absolute minimum as well, then you would label that one as well. If it just says list all relative mins and maxes, then you would just list it as a relative minimum. Does that make sense? Other questions on that one? Alright, well let's all read